All right, so let's talk about the hardware platform. All right, so in X2, sorry, I should go back and say in X1 we had a 20, a 10, and a 40, based on 400, 800, and 1.6 terabyte drives respectively. In X2, we have two models, X2S and X2R. Minimum raw capacity, 7.5 and 34.5. Largest capacity, 28.8 and 138. Why do I pay attention to that? Is let's look at typical effective. And typical effective I just find is a DRR of 4:1. Reasonable number. In a full expert configuration, that's a 72 drives full. We're at 89.3% raw to usable. Pretty awesome. So that gives us an effective capacity on the small box at 100, almost a little over 100 terabytes, and at the large box, almost 500 terabytes. To compare to X1, the largest configuration, what we call the Beast, was about a petabyte of capacity. So we're able to do basically about a 4:1 reduction in capacity. Make sense? Currently supporting up to 4 XBricks, and over time we'll add back support for 8 XBricks in the X2R. We don't plan to do that currently in the X2S. You might ask, when do you use which? Right, always a consideration. For smaller workloads or very highly deduplicable workloads, X2S makes a lot of sense. One of the things we've done as part of X2 is we've introduced a sizer that is available to our partners as well as our internal employees, and it gives you, based on your inputs, it makes a recommendation for configuration, taking into account performance, capacity, and performance end up being CPU on the controllers. It takes into account memory as well, and it finally takes into account economics. So it recommends the best configuration, and then we give you where you're at on the scale in terms of how much is being used. So we try to make that as easy to use for our partners that they can then bring to their customers as well.
Functionally, does the S and the R, other than the size allocations, CPU differences, number of port differences?
Yep, talk about it right here.
Perfect.
Awesome. You're great straight man. All right, so what's different, right? So cores, absolutely the same between X2S and X2R. Memory, a little different, right? So in X2R, I have a terabyte of RAM on each controller. In X2S, I have 384. I have less memory. Ports, still the same. 16 gig Fibre Channel, 10 gig iSCSI. One of the things that we added in X2 is if you're an iSCSI customer, you can actually convert the Fibre Channel ports to be iSCSI. You cannot do the converse, but you can convert the Fibre Channel ports to be iSCSI. And then the back end differences between X2S and X2R are the drives. So 400 gig drives in the X2S, 1.92 terabyte drives in the X2R. Sense? All right, let's see here. What else did I miss here? Other things we tipped up, right? So SAS 3.0. So 12 gig SAS. InfiniBand, we actually moved up to 56 on there. And then, of course, for those of you who are worried about bandwidth on Fibre Channel ports, we now have 16 gig Fibre Channel, which is still usually end up not being a limiting factor on it, but we do now have support for 16 gig for customers that need it.
Todd, just on the drive side, one of the things that was probably aimed at XtremIO as a platform from some of the other vendors was the ability to use slightly cheaper quality media in the platform.
Yes.
Are you still just using MLC? Is there a TLC intention?
No, actually, yeah. So that's a great question. So one of the differences, and actually it makes a huge economic difference, is we were able to move to less write per day drives. So we're able to drive less write per day, one to 3 write per day drives in X2. So it gives us some flexibility. And part of the reasons why, Zvi will talk about it when he talks about write boost, because that's one of the things that we implemented so that we could do that. And it certainly makes the economics a little better for us.
Okay.
Question? All right, so let's talk a little bit about scaling. All right, so scaling, right? So let's start out with this base configuration, 18 drives, 2 active controllers. We'll spin up, each of these represents 6 SSD drives, so it gives me 72. It gives me 138 terabytes raw. I can go across. In X1, remember, it was 1, 2, 4, 6, 8. We liked even numbers, not a big fan of odd numbers except for 1.
And they had to all be the same.
I'm sorry?
They had to all be the same.
Yes. So one of the things we did is we said, all right, now we like odd numbers. Odd numbers are cool. So 1, 2, 3, 4, for example, right now. Over time, it'll be 5, 6, 7, 8 as well. Gives us, over time, about 1.1 petabytes raw and a 19-inch rack. We're giving about 5.9 petabytes of effective capacity at 6:1. So
Very minor point?
Yes, sir.
You should keep your data reduction comparisons the same across the whole slide deck.
I will tell you why I did that. So I had, this is more of a max configuration, looking at kind of theoreticals, and then the effective. So I wanted to use what we saw in most customers. So I actually did think about that.
You're digging your hole deeper.
Incredible.
Actually, a really quick question. Going from an X1 to X2 forklift,
Yep.
and you can't coexist in the same cluster. Obviously, different technology, right?
Different clusters, yes. Yep, and we'll migrate using things like SV Motion, for example. All right, so DAEs, those of you who didn't see the...
Any commitment for X3 to insert into X2
Well, we can't
clusters?
talk about futures. I would be shocked if we didn't do something like that. That's about all I can say.
Okay.
And things like NVMe that was talked about in your platform, we're going to do it across all of our platforms as well. So, all right, so...
And let me say, I like the new DAE.
You like our new data? Thank you. So it gives us some flexibility, right? So it allows us to kind of load, it's top loaded, right? So you can add 6 drives at a time, as I mentioned before. You don't have to fill the DAE, right? So in this case, you show the example here, right? So this was 18 drives, I grew to 24. That was not a full DAE, doesn't require you to, but it gives you some flexibility in figuring out what's the best price performance capacity play for customers, for example.
What's the DAE to XBrick controller interconnect? 12 gig SAS?
12 gig SAS. Yep. All right. So let's take a look, drill into this DAE a little bit. All right. So what we have in X1, we had a single XDP group, and that was 25 drives. In X2, we've gone to, in that 72 drives, we've gone to the ability to have 2 DPGs. Each represents 36 drives in the environment. And allows us, of course, to have 2 failures, simultaneous failures, in each of the XDP groups at a time. The math on that is pretty astronomical, but I suppose it could happen. So we do want to go ahead and protect against that. Questions about XDP at all? Okay. All right, so battery backup units. So those of you who watched Steven's Periscope will saw that there is no more battery backup units in the XtremIO. We removed them. We replaced them with NVM. There's much rejoicing. I've never heard anyone say, I miss battery backup units, because they're things that have to be replaced, right? So 3-year lifespan somewhere in a BBU, maybe 4-year lifespan. You got to figure that out. So the NVRAM, we said, all right, let's put NVRAM and a supercap in here. It reduces our cabling count, reduces complexity, reduces our overall rack units, which is good from a density point of view.
And points to the guy who made the supercap look like a detonator.
Yeah, you like that? Let's have to take that back to Ronnie, our PM.
Neck extension too.
And it allows...
Super that way.
Yes.
Extra super.
Yeah. And so it allows us to go ahead and also to have odd XBreak support. Because one of the reasons why we added in duals was, you remember you had to have two UPSs to power the controllers. So now we don't have to worry about that. If you're interested, you actually can take 6,000 charges against this, right? So your data center could theoretically, or your customer's data center could theoretically lose power 6,000 times. If you do, your last problem is data. You need to really work on better power. But we do have that support. And of course, they are field replaceable units like everything else.
I have a question though.
Yes, sir.
So I'm seeing customers take these units and, the life cycle on these units from a controller perspective and drive perspective, they're expecting 5 years, 6 years out of these things now, right? So as we all know, Intel drives their TikTok and all that kind of great stuff. So these platforms are going to change within a 6-year period, probably about 2 or 3 times.
Yes.
So are you guys committing to, when the X3 comes out, will I be able to mix clusters with an X2 and X3?
I can't commit to futures because we are in a non-NDA session, as you know.
Is that planned? Is that the idea? Is that the general principle?
The general...
Is there any edge I can work around where you can get
that?
I mean, that's a fair
X1
question.
to X2, you're saying, get out of here.
We're saying, we're, by the way, for example, X1 customers still continue to have drive support. We have not announced the end of life.
That's fine.
We will still have...
Yeah, but
more.
there's a big difference.
Let me expand on that.
I have
because
multiple clusters.
Yep.
And I can have a cluster where these are the original nodes I bought that are in the process of being evacuated, and these are the nodes I bought 2 years ago that are the core of the system, and these are the brand new nodes that are in the process of coming in. To really use the term scale out, you've got to give me that.
I want to jump on that because
I have experience with a hyperconverged solution, which I
Yes.
won't name,
Yep.
where we are running into big problems because of processor differences, because we cannot mix and match. I mean, it's a different case.
Different
Your
architecture,
storage
yep.
solution, it's hyperconverged. It's a bit different. But this is causing a lot of problems into expanding clusters. We have to increase the overhead in management and so on. So I think it's really an important topic here to see if you can mix and match.
And you mentioned the management. The management does manage.
Yeah, so well, it's true. The managed clusters. I absolutely get your point. So I will tell you that it is our commitment to make sure that we meet the goal, meet the requirements that we've stated, which is long support for both the X1 platform and the X2 platform. And we know that there is, for example, the ability that there are tick-tock changes, for example, in CPUs, drives happen, right? So we've had to deal with drive changes, and we expect that to continue, and we expect to drive forward that. So unfortunately, in a non-NDA format, that's about all I can say. But know that we are cognizant of it, and we are driving to do that. So, all right. So availability. Back to your question. I hadn't forgot it. I just knew it was coming up. All right. So redundancy, right? So we have it's like Noah's Ark style, 2 of everything. Dual vault RAMs, InventBand connects, ports connectivity, 2 of everything. The other interesting things we do as well. All right. So. We don't mirror. We actually journal, just like a database, right? So the database and the journaling is set so that we make sure that we have redundancy across the environment. It's a little different than some of our other high-end platforms. But it's just a little different way of doing things. What we do is from integrity checking. What happens is before an I/O goes out, when it's a read, I go ahead and do another hash of it. So after I've read it up from disk, I hash it again and say, all right, is this what I asked for? Does it actually match? Because it's very important from a data integrity point of view. I also do, of course, FCRC checking, both at the drives as well as at the memory as well. So I'm continuously doing fault detection and healing in that particular environment. Make sense?
Yep. And what's that schedule? Is it every 2 hours?
Every time you read the data.
All right.
Very simple, right? You read the data. I'm gonna go ahead and take a hash every time.
Can you force a scrub?
Can we force a scrub?
Yeah.
Force a scrub.
What do you mean by
You're
that?
talking about like sniffer,
Well,
like the old sniffer on the Clarions.
When you do the hash checking on reads, very similar to a ZFS system. Now, you guys are obviously building much higher end systems than ZFS built on cheap hardware. The idea there is they usually recommend that there's like once a week on cheap hardware, you do a full scrub. You read all the data, and effectively, when you read all the data, you get your hash checksums checked against.
Sure.
We don't have such a thing today.
Other than if you were doing a backup, that would be by nature doing it. Right. That's what happens most
true.
times, right? On a rotating schedule, like most customers do back up their data, hopefully.
Any move of the
Yeah, but
data, any
I'm like-
transition is verified and checked along the way. The cast gives you a natural verification both of the correctness of the content and also the match of the content to the address.
Exactly.
So that's we get it for
You're getting
free.
all the read. It was
We don't need to do much work for it.
Yeah.
But the thing you're talking about is also something we are looking at that areas. It depends also on the drive quality and.
Well, it also, when you're reading that much stuff, you're going to have an impact. You're going to have some scheduling issues to make sure it has zero impact on coast
For
performance.
sure.
Yeah.
For sure.
Okay.
Yeah, and if you look, it's like the one I know where we go. For example, Clarion used to have sniffer, right? And sniffer ran because spinning drives have rot, right? I mean, it's by nature.
Yep.
Flash drives themselves, most cases don't really have that, right? And if they do, we have ways of dealing with it, right? Using XGP.
And we are using also drives that have internal RAID, so they have internal checks and protection
Yeah, so you've
by
got the
nature.
whole stack. You've got the ECC in
Absolutely.
the memory, you've got the
Yep.
ECC in the memory, and the actual each controller and each.
Which are multiple levels, and that's a good high-end architecture has that, right?
Yeah.
Right. So it's one of the differences between some dual control architectures that don't do that, right?
What are some of the messages that you're getting back from the field with this latest generation of XtremIO?
So definitely it's been very positive. Now we're in our quiet period because we just ended our quarter, so I can't talk about results, but I will tell you that they've been very positive.
What about from a support perspective?
We have a great availability on XtremIO X2 currently.
So you're saying that there's a very low number of tickets being opened about XtremIO.
Yes.
Is that what you're saying?
Yeah, I will tell you it is actually less than even our expectations, right? So one of the things that we do in our platform is every release has a base is across all of our portfolio, not just XtremIO, as we keep increasing the quality bar. And I will tell you that our expectations for the number of tickets we've had have been less than what we've actually had. which is good, right? That's good for the guys like Zivy and the engineering team have done their job, which is what we've asked them to do.
Do you have any idea on the ratio of the different generations of XtremIO that are out there at the moment? What the blend is?
I cannot give you that data. I'm sorry. I do. I know it, but that's unfortunately very proprietary.
I heard that I do have it, but I can't tell you. But you got on it right quick.
Yeah. Sorry.
What's the most common brick configuration that's out in the field?
1X brick is by far the most common because multi-X brick is more than 50%. But it's still 1X brick is still probably the most common. And that trend is continuing in X2, right? So, and what happens a lot is people start with one and they grow, right? So it gives us
But not by far. We have,
not by far. No, that's the interesting
not
thing.
by amount of bricks.
It's not like single is double the amount of the other ones, right? So single to single to two there isn't a large difference between them.
And what's the most common access protocol that they're using in the field?
Fibre Channel, always. Yeah, Fibre Channel. That's across all of our high-end storage platforms. Fibre Channel is by far the dominant.
And what speed of Fibre Channel interface is supported by the X2?
16.
16.
Yeah, 16. So go 16, 8, and 4.
And 5.
So I suppose if you have 2, you're out, but quite frankly, why are you buying a high-end flash array with 2? But one of the things we actually do as part of our partner effort and part of our internal sales effort is we look at that as part of our assessment process. So one of the things that we've done a lot of work with, and this is across the portfolio, not just XtremIO, is looking at not only the flash array, because remember, there's always going to be a bottleneck. In a lot of cases, in the past, it was storage. Right, so if we take storage out, and all flash arrays take storage out of the bottleneck may move to the SAN. So we as part of our assessment process, we look at that, and then we may need to, for example, look at doing an upgrade if they were on 4 gig Fibre Channel, for example, or 8 gig oversubscribed.
And what's the most common use case that actually resonates with XtremIO?
The most common use case is databases with large amounts of snapshots currently. Yeah, that's by far the largest deployment of XtremIO. VDI actually represents a very small, in terms of dollars, a smaller component of the architecture. But if you look at, if you have a VDI environment, say 4,000 users, that's a single X brick with a certain amount of drives, depending on depending on your configuration. A database environment might be, 30 terabytes, 60 terabytes of flash. Right.
Does VX block the 540? Does that make up a large percentage of your XtremIO sale?
We have there's a decent amount of uptake in the 540, absolutely.
And what's the use case that is not a good fit for XtremIO?
Yeah, so great question. It's kind of getting back to what Vince said earlier, right? So things XtremIO doesn't do. We do not do mainframe. We do not do AS400 IVMI series, and we have no plans to do so. And we're not going to do file. Right. So those platforms. Not a good fit for XtremIO at all. If you have data that doesn't dedupe well or doesn't compress well, the economics will tell you that XtremIO is not the right platform for you.
So you're not targeting media and entertainment?
I'm sorry?
You're not targeting media and entertainment?
Not on this platform. There are many platforms that we are targeting media and entertainment. I will tell you, for example, Isilon. Not XtremIO, but Isilon has a great story.
Todd, it was a joke. Just let it go by. Yeah.
I will tell you, I am not. If you ask me a question, I will give you an answer.
Low ball in the dust. Don't swing.
I take it. I want to make sure that you walk out here, and those of you on looking at Twitter as well, get the answers to your questions. That's part of my job, right? I want to make sure you get the answers. All right. So, sorry, availability we good? I think we are.
Good, yeah.
All right, so let's take software-driven performance. So compression, right? So we did some compressions, about 25%. We'll say, well, compression's what, about 1978? Compression came out, lossless compression somewhere there. So it's 30 years, almost 40 years old now.
Wait a minute. I'm sorry to do this to you. There was one thing on that slide. You didn't do. You almost snuck by us.
Okay, what did I think?
Non-disruptive upgrades.
No, I was, okay, non-disruptive upgrades, yeah.
That's had some history with XtremIO.
For sure.
Please describe the new process by which it works.
Sure. We've actually done this across X1 and later releases as well. So one of the things that we added in X2, and I'll just talk about the differences of things that we added in X2, is, for example, when we're doing an upgrade, there's the concept of what's called the SIM. That's a system-wide management module. It's actually here on the upper left-hand side. One of the things that we do is we actually go ahead and preload that. So in the past, we would basically have it start up, and it would have to figure out all of its things, and then it could start working. Right? So there's some time associated with that. So what we do is we basically start in the background, we let it preload, we let it get information from the old SIM, and then can take off. right? So that speeds up significantly NDU in the environment. The other thing we're doing as a general purpose, and we've done this across X1 and X2 as well, is we want to reduce the amount of times we have to do things to the storage controller. So inside of the non-disruptive upgrades, there's two components. There's what's called the XIOS upgrade, or the Xtreme App upgrade, which is the operating system of XtremIO. And then there's the underlying, what we call the firmware, which is really the underlying storage controller's operating system. What we're doing is we're trying to reduce the amount of times we have to touch the underlying storage controller's operating system, because that reduces the impact of the system. So we're driving towards that to basically, for example, not have to do that as often, and just upgrade XIOS. And XIOS is a much easier process and a much shorter process from an NDU point
What
of view.
about a rollback?
Rollback? So actually, XtremIO has always done this. If XIOS upgrade does not succeed, it will actually automatically roll back for you.
All right. I mean, are you guys updating are you updating your metadata tables, the format of those as you go from code to code to code?
Sometimes.
So will it back out those changes, go back to the older version?
So what will happen is the metadata, the upgrade either succeeds or fails. It won't change the metadata until it succeeds.
Well, what if you have to roll back after you've finished and it succeeded, and you need to roll, for whatever reason, you need to roll back to a previous version of code?
We currently do not do that. We roll forward, fix the problem.
That's, okay, thank you.
Make sense? All right, let's see here. Compression. All right, so compression, been around for 40 years. All right, so why do we get better compression? So in X1, we basically had 3 compression buckets. You either were at 8, 4, or 2. If you were 4K plus 1 byte, you became 8, which means you're not very efficient. We got some decent compression, but we needed to improve that. So in X2, we said, all right, let's look and add more buckets. So in X2, we now have 15 buckets. You might say not 16, why not 15? Why not? When there's 16K, why not do 16 of them? Math-wise, there's one of them where it didn't actually get us any advantage. So we have 15 buckets, and that gives us an improved compression rate by about 25% in the environment. So that gives us overall, and that's taking into account the block size change, for example, as well. Questions? All right, so example, this is an Oracle customer. They were at 3.5 DRR in X1 and X2, they're at 5.1. Right, so just taking advantage of the compression enhancement, they were able to pack more data in the same amount of flash.
Are these native Oracle connections or through hypervisor?
I'm sorry?
Native connection.
This one was
Oracle.
particular was hypervisor.
It is hypervisor.
Yeah, almost everything we do is in hypervisor, right? So we do support physical, of course.
I'm just curious if the numbers are still working out as well.
Yes.
With the virtualized Oracle rather than
I would say
physical.
most of our customers live in a virtualized world, right? So it's a very rare customer that has a physical server anymore. Across all of our platform, but XtremIO is most specific in that.
It says that this is for the X2 beta. Have these numbers changed at all since X2 is production now?
No, they haven't. This would happen to be a customer that wasn't part of our beta. So I have the nice results for them.
Okay.
We do have customers. I just haven't got results from the customers. But from the data I've looked at so far, and we have, as part of our Dial Home system, we can kind of look at that. Our overall expectations have matched what we expected.
So since you're talking about beta results here, since when the X2 platform has been live?
XtremIO X2 GA'd on August 31st. So we're about, call it 2 months and some change.
Okay.
When is the HTML5 interface going to go GA?
His GA. His already is.
Okay.
GA is part of XtremIO X2. So I think what your real question is on
I'm
X1.
talking about in X1.
Yeah, so
Sorry.
X1 this month.
Okay.
So that's the one feature I can actually tell you because it's in this calendar month.
Right. Because in my current version, it says Tech Preview down the bottom.
Yes, Tech Preview. I would tell you, Tech Preview, we actually took a lot from that and learned, and basically, if you've noticed, if you've done multiple releases, we've evolved the UI. And I would tell you, most customers use the web UI certainly for performance reporting and reporting because it's an excellent platform for that. And most customers actually did configuration changes on that as well. And we're GAing X1 support here in November for that web UI, and it will take off that Tech Preview. So, and it'll be the exact same one GUI that we have in XtremIO X2. All right, so here's a quick VDI example. How am I on time? I should look on that.
About halfway in.
All right. All right, so VDI. All right, so let's see here. All right, so this is 4,000 virtual desktops. So VSI Sim Max here. So 2 controllers, 18 SSDs. So I'm not having a big configuration, right? So this is, forget this, pretty much a min config box. So kicking on 4,000 VDI sessions. So we're able to go ahead and not hit here my maximum here. So interesting. Zvi will show you an Oracle example when we look at Write Boost. All right, so let's look at the booting the desktops. We kind of showed you that here. It took about almost a little less than 8 minutes, about 0.2 seconds a desktop, so it's booting very fast. And then some interesting from a data reduction point of view. All right, so getting 40.4 at 1 DRR. Obviously, these are focal and desktops that are very, very common in the environment. You won't see that in Oracle database, but we will see some excellent results as we saw in the earlier slides. All right, so cloning. All right, so we enhanced that. So basically VAI cloning. So we basically doubled the performance of cloning in X2, going from about, quadrupled. So it used to be about 20 gig a second that we could go. Now we're going up at 80 gig a second for the performance.